Hello, everyone. I'm Ioanna Nika. I'm a data scientist at Erasmus MC, and I'm working on the Darwin EU project. So the software I'm presenting is the DarwinBenchmark package. It's a package we designed for the Darwin EU project to benchmark cohort generation and our analytical packages in OMOP CDM databases. So just for context, the Darwin EU project, so we answer epidemiological questions asked by the EMA. So we get questions, then we have a number of data partners across Europe that we collaborate with. We're responsible for writing the protocol and the analytical code. We distribute those across the databases. We get results back and we report results back. So through this project, we have a growing number of databases that are being mapped to the OMOP CDM in Europe. Also, we have to use our analytical packages quite a bit and also develop new analytics. And as part of our study code, we have to generate a lot of cohorts on Atlas and generate those across our network. So for our studies, we have the two different types. So we have the simple studies, which have a timeline of 3 months. So to execute the code and also generate the report. And then for complex studies, the timeline is 6 months. So ideally, when we run our analytical code, we on the data partners, we don't want to have any database issues or any errors with our analytical packages or inefficiencies, because that's going to impact our timelines, which are tight. So to be able to capture those issues proactively, we have developed DarwinBenchmark. So it does a few things. It it evaluates how long cohorts need to take to generate on the different data partners, how our analytics, how their runtime is across data partners, and whether they can execute without errors. And it also provides a Shiny so that we can visualize the results. So in short, so for the cohort benchmark, we want to see how cohort entry criteria and inclusion rules can affect runtime. So for that, we have 3 standard cohorts that we run as part of the cohort benchmark. And the first one is a simple cohort with some broad entry criteria, and the rest have some more selective criteria for cohort entry, but then they have more complex inclusion rules. In terms of what patients they match, that's just frequently occurring concept that is across different domains and across the network. And they capture, they match records across these different tables: condition, drugs, observation, measurements, devices, and procedures. And for the package benchmark, our analytical packages, they have some standard workflows, a benchmarking function that we run, and we track whether it could be completed successfully on the data partners. And also we track the runtime execution of the subtasks of this workflow, which are also standard. The packages that have such a function are incidence prevalence, CDM connector, drug utilization, and cohort characteristics. And for any package to be included in the DarwinBenchmark, all it has to do is expose such a function, and then it can be included. And as I said, we have a Shiny, and I'll go through the Shiny quickly. So the first view is the cohort benchmark. So as I said, we have 3 cohorts of increasing complexity. And then I'm showing you results from 3 databases: IPSI, a Dutch one, and 2 IQVIA databases, a German and a Belgian one. And you can see how long it took to generate per database each cohort. There are some more tabs for database details. For example, you can see the person count and the relevant records, so the sum of records from the tables we match records from. And you can see, for example, that the German database has the most amount of records or subjects, but then it's IPSI that takes the longest to generate the cohorts. You can also see the cohort entries and subjects matched by the databases. You can also see across versions how long each cohort took to run. And except from version, you can also see cohort entries or how big the database became across database versions. And the second view is for the package benchmark. So here, for example, this corresponds to the workflow run for CDM connector on IQVIA Germany and Belgium. So you can see the German databases which has most data. It actually takes across to run the different subtasks. And also, you can also see version trends, so that for IPSI, for cohort characteristics, for example, the different subtasks that we run are stable across database versions in terms of runtime, and it is a large-scale characterization that takes the longest. So that's what the package can do. Thank you for listening.